Hi there. In this episode of Sample Space, we're going to be talking about word embeddings. And it might sound a bit strange because we have transformer models now, and it kind of might feel like word embeddings are kind of out of fashion. But it turns out you can actually make them very performant if you apply a couple of tricks the right way. In particular, I'm going to talk to Thomas van Dongen, who is running this thing called the Minish Lab together with a collaborator. And they have found this interesting distilling technique where you can take a pre-trained language model transformer, embedding kind of a model, but then apply some aggressive distillation towards word embeddings to actually get really performant and especially lightweight vectors out that you can actually use for a bunch of use cases. It performs quite well on a lot of benchmarks, and there's some interesting technical details that we'll discuss in this one. I hope you really like it. Hi, Thomas.
Hi, Vincent.
Hi. So, yeah, we met briefly online before. The long story here is that I've been trying out this model-to-vec thing in one of my live streams that I've been doing over Probabl. And after digging a bit deeper, I thought it was kind of an interesting story there that I wanted to talk to you about. So we're going to talk about lots of things, but we're going to get started with this model-to-vec thing. So I guess the simplest way to get in is like, hey, model-to-vec, you made a thing. What is it? Just to immediately dive right in.
Sounds good. So model-to-vec is our static embeddings for the modern age. At least that's what we think of it. We can do a very long technical rundown of what it is, but to stay very brief, it's just static embeddings have gone sort of out of fashion in favor of transformer-based embeddings. We, Stefan Tokens and I, who set up model-to-vec, have always stayed really interested in static embeddings and have come up with a way to make them much better and more performant last year. And that's what model-to-vec is.
Cool. Okay, so the part of what I'm hearing then is the need for something more lightweight. That was kind of part of the pursuit then, I think. And part of me just wondered then, like, how did that maybe get started? Because you're not a super recent graduate, like even out of graduate school for a while now, but I think you've done like artificial intelligence type stuff, I guess.
Yeah, I have a background in artificial intelligence and information science. And I've indeed been working for some years now already. And I've always had this interest of doing something open source, but always felt like my ideas weren't good enough to put out there. And this is the first time that I really felt this could be something. This could be a hit. And that's yeah.
Interesting. So I'm kind of interested in that. I'm assuming you have done the off, like, oh, it's weekend, let's work on a fun thing. Like, I'm sure you've done, hey, let's do a brain fart in a notebook. Lots of us do that. But what was it about some of your brain farts that made you think like, do I want to turn this into a Python package? Maybe not. Like, it sounds like you've hit a milestone with model-to-vec in a way.
Yeah, exactly. I always felt like whenever I built something and I started looking, does this already exist? It in some way already existed, and then I didn't feel like there was a need for me to publish it. And with model-to-vec, I really felt like for the first time it was something that didn't exist yet, that could solve a lot of use cases, and also could just be something that I could use at my own day-to-day job a lot. And that's those three reasons basically set us up to release it as a package.
So one thing that I'm kind of curious about in this sense is that, like, I never studied something of data sciencey stuff. Like when I was in college, we had econometrics, we've had operations research like 12, 15 years ago or something like that. So, I did applied math, and this whole data science thing was super new, and you would have to figure all of that stuff out yourself. Like scikit-learn was only just getting kind of popular when I was doing data science stuff. But I can imagine in your case, right? Like you probably, if you take an NLP course, they kind of go, transformers, here we go. Like we're immediately going to do all those tensor stuffs. Is this an accurate characterization? Because I'm kind of interested in the fact that, hey, it sounds like someone who's gotten teachings in like super modern technologies to actually take a step back in history. And part of me is kind of wondering, what's the motivating factor there? Like, is this a fair characterization, by the way?
I think so. At least I started a little bit before transformers. So I always felt like I hit the sweet spot when it came to being in college and getting the right knowledge, because when I started, the big libraries were just releasing, like Torch and TensorFlow. You had Spacey releasing. So a bunch of libraries were releasing at that time that we immediately started using the first versions of and learning. And then obviously a couple of years later, Transformers released, and I think everybody did their thesis on something related to Transformers because it was obviously a very big deal. But I did really start with these more traditional embedding methods, like word-to-vec was really popular, but also TF-IDF. Those were the kind of things we were taught in the first couple of years.
Right. So it is kind of fair to say that you were taught these word embedding things, so you still have the good memory of the word embedding. Yeah. And then eventually all these transformer models came around the corner, but you still remembered the word embedding. And part of that might have helped sort of in the design process of models-to-vec then in a way.
Yeah, I definitely think so.
It's kind of interesting because one thing I'm very fond of right now is that I have these LLMs at my disposal that might help me code, so to say, but I'm very happy that I learned how to code before the existence of LLMs. And it kind of sounds like something similar happened to you, but then with word embeddings and transformer models, that you were very happy that you actually got taught these word embedding models, not just as a chapter, but like as this is how you do it, before actually being exposed to these super new models that require heavy compute.
Yeah, I completely agree. I think it really changes your way of thinking. If you've ever interacted with like these small, lightweight techniques and the power they still offer, I think a lot of people would just jump straight into, well, first it was transformers, now people jump straight into LLMs. They miss some of that context. And also, I think a lot of people even don't compare anymore to older techniques. While in a lot of cases, they're probably going to be work just as well for you and be much cheaper, much faster, much more scalable.
Yeah, my favorite trick for like just basic text classifications is still just a scikit-learn pipeline with a count vectorizer logistic regression model. And it turns out that that's a benchmark that's fairly hard to beat. Like many approaches don't do that much better than that. But I guess there's still a need for something pre-trained in that sense. But it helps to like I can kind of see where the motivating factor kind of comes from. You were taught these word embedding models, you kind of like them, and all these new fancy models came around, and then partially in the back of your mind, I guess, then there was always this idea of like, hey, do we need the heavyweight models? Can we maybe still get away with the lightweight embedding stuff? And that makes sense. But then what gave you the confidence to really make an open source package using these techniques? Was it that you ran a benchmark yourself, or did you, like, I'm assuming you're also applying some of these techniques in your day-to-day work as well?
Yeah, it was a benchmark indeed. So in my day-to-day job, I still make heavy use of word-to-vec embeddings at least as a starting point for all my models that I train. And we usually evaluate on things like MTEP, Massive Textual Embedding Benchmark, which covers a lot of different tasks. And Stefan and I were just experimenting away with an idea that we had, which turned into Model2Vec later. And we saw some really promising results on MTEP. And that was the point where we started thinking, okay, this might turn into something. If we can iterate upon this and improve it even further, then we might have something here that can really work.
And we're going to get into the details of what Model2Vec does in a bit, but maybe because you mentioned MTEB, to the listeners at home, like my understanding is that it is a benchmark, and the way the benchmark works is we just have a collection of tasks and we average over all of them. Is this an accurate characterization, or would you describe it differently?
That is true. Yeah, you have different subtasks that are quite popular, like classification, retrieval, semantic similarity. For every one of those tasks, you have a number of well-known data sets. You essentially evaluate all of those data sets, and then you get a score per task and also an aggregate score for MTEP, for the leaderboard, essentially. And it's also a pretty popular Hugging Face space that's turned into a leaderboard where you can just see how you stack up against other models.
Yeah. And I guess like some of the tasks might be more retrieval based, I'm assuming. And I guess for classification, do you know what data sets people use there? Because the thing with these benchmarks is always it's a little bit tricky to over index on them, because in the end, they're still just a benchmark. And it could be that you're like, I'm always worried that I do classification, but my data set is just super different than the classification benchmark data sets that we've got, leave alone that there might be label issues, etc. Like, did you ever dive deep into that, or did you just accept the number as is?
Yeah, kind of. So I think usually you always, if you have internal data for your use case, then obviously you want to evaluate on that. But I think MTEP is a nice way to at least see on some general, well-known data sets how you compare to other models. I mean, I'm not saying it's perfect, but it is, in my opinion, one of the better ways to see early whether you have something that can work.
Yeah, if you score pretty well on all of those different like numbers, then odds are you're doing pretty good, because it's at least not trivial to game just because there's diversity in tasks there. So that's, if nothing else, a good win. But okay, then let's now start talking about the technique, because I think it's an interesting technique that you're applying. Like, what can you do to actually get good word embeddings these days? Like, what are the main tricks that people might want to sort of learn more about?
So you mean static word embeddings or general word embeddings?
I guess static is the main thing I'm going for, because that's what Model2Vec does. But take us a bit on the path that you took to improving lightweight systems, I guess.
Yeah. So I think there's been some very well-known techniques for generating semantic word embeddings. Obviously, we start very early with TF-IDF, similar to count vectorizers. And then around 2012, 2013, you get Word2Vec, which at the time I thought was amazing and really cool. I still think it is, actually, which is just this way.
Glove is a word that comes to mind. Right? I think Google wrote a paper, they call it glove for whatever acronym reason. But instead of having ones and zeros in an array, you got these floating point numbers, and you can do fun stuff with them because they're dense vectors. That was kind of the main new thing.
Exactly. Yeah. I think it's Stanford open source some of those glove models, and those became really popular. And then after you had byte pair embeddings as well, and fast text. And I think though that generally covers everything. And I feel like after that, there wasn't much development, at least in static embeddings, which I've always found odd that people are still using these static embeddings from 2014, 2015. At least I was in 2024. And that was also some of why we really wanted to see if we could improve this, because it felt like there hadn't been much development in this field, even though there had been a ton of development in machine learning and AI in general.
Yeah, you're kind of right. I can remember, I think 2012 was when I started, and then 2015-ish, you start seeing these more neural things sort of over the horizon. And then it kind of felt like 2016, 2018, that was word embedding time. And I guess the byte pair thing and the fast, like, not fast API,
text.
that's the one. So many fast names these days. No, but the fast text one, like those were kind of cool because they do subword embeddings in clever ways. Like instead of doing the whole word, we can maybe chunk it up a bit, and then you get an embedding for each subword. And that was kind of a clever trick. And I also kind of like the thing that some of those techniques were eventually used in transformers, but it was like a 2-year period when everyone just started training these random word embeddings on random corpora in lots of different languages as well. And that was kind of the innovation mainly. And then I think 2017, this kind of changed because of the introduction of this paper, but it took like a good year or two before like pre-trained transformer models kind of became ubiquitous, I think. I don't know if you've had a different experience of that, but that's kind of how I remember it.
Yeah, I think there was this gap. I think the attention is all you need papers from 2016, and then there's an adoption period of about a year. So you do have this gap between around 2015 and 2017. And obviously, after that, it was still a long way before we got these general embedding models pre-trained. It started with encoder models like BERT, and then slowly but surely you get these fine-tuned models for specific embedding tasks. And now we have these great embedding models that can do everything, basically.
I think part of it, I'm kind of curious how you experience it, but part of it also kind of felt like Hugging Face had a big role to play in that one, just because they kind of made it a pip install. And you kind of got it. Yeah, and like I do remember the byte pair one and the fast API, fast text one, and I guess also the spacey one. They did all give you vectors, but they did all kind of have their own little weird API, and they kind of all work differently. And I guess Jensen was also a library that tried it, but it wasn't necessarily one big standard. And I think that's been the main thing that Hugging Face contributed. It's just a pip install and a string, and you've got it basically.
Yeah, that's true. Yeah, I remember when I started with transformers by trying to write it myself in TensorFlow 1, which was horrible. And then while I was working on that, the first version of Transformers released, I think, and everybody was raving about it, at least at my university. And it was so nice. It was so easy to use. You had all of this complex code just hidden behind a pip install, and it just worked.
Yeah. I mean, I can't imagine that there's like a plus side and a downside. Like one thing, if I look at the Scikit-learn API, for example, like I really love the fact that it's fit predict, and that's kind of all you need to know. But then I do wonder if there's anything that's lost if you don't know how to implement your own linear regression, maybe. Like I do think that's an exercise that sort of helps shape you in your career in a way. I wonder if maybe there's something you might lose if everything becomes too much of it's just an API call instead of we know the parts under the hood. But I do want to acknowledge that totally more people started using these techniques, and at least more people started to play around with them as well.
Yeah, exactly. You get a lot more people who can play around with it, but also a lot less people who are really familiar with what happens behind the scenes, I think. That's always an issue, I think. Like the easier you make your package and your methods, the harder it becomes for people to actually learn, because they're not forced to learn anymore. They can just run a 2-line piece of code and it works for them. I don't know. I always feel like people who really do want to learn will still do it themselves. At least that's how I've always perceived it. And I hope it will stay that way.
Yeah, but then it becomes instead of reading the docs, you just dive into the code yourself and spend an evening and kind of wing it that way. That makes sense. But okay, then we're moving along the time now. And okay, then Transformers have arrived. And have you graduated at this point already or not yet?
Not yet, no.
So Transformers were around. Probably Sentence Transformers was also around that time as well, I think, right? Like ish?
Yeah, somewhere 2018, 2019, something like that. It's from the S-BERT paper, which 2019.
I vividly remember using the universal sentence encoder from Transformers for the longest time. But there was just a moment where just getting that to work, installing it was just too much of a pain. And then I just switched to S-BERT since. Like that package has basically replaced most of my embedding needs at this point. But okay, like you then start graduating. We're a couple of years forward, and okay, let's say Hugging Face is well established, BERT is well established. What happened that led to Model to Vec then?
I think it was so. There's some years in between this point, right?
Sure.
And Stefan and I, we know each other from my first job at a startup. He also worked there, and he left that company since then. I'm also working in a different company, but we stayed very close, and we always think about cool ideas, at least what we think are cool ideas, like a bit of sparring. And for years and years, we've just been sending each other these tiny little ideas and things we could try. Sometimes we did try them. Most of the times they didn't work. And with Model to Vec, it was the first time that I think we hit something that worked, or at least we got the impression that it could work. But that was a process of, I think, years for both of us.
Right. So it was an overnight success after trying for a few years, kind of.
Exactly. I think we developed Model to Vec in a couple of months before open sourcing it, but there was a long process of just talking about ideas for many years before that, I think.
Was it mainly looking for the good idea, or was it also like once you've had the idea, just making sure the numbers were right? I can also imagine if you've been at it, like trying it out, and you want to maybe open source it, that you also feel the pressure that, you've got ironclad arguments for people who doubt it, right?
Yeah, exactly. Yeah, I think we're both academic people in that sense. We value real benchmarks and comparisons. So it did take a fair bit of time for us to actually feel confident enough to open sources, because we wanted to get the theory right, we wanted to get the numbers right, we wanted it to be, as you said, like fully proof against
arguments.
Yeah, against arguments. Yeah.
Okay. So then let's talk about the technique then. So I'll just have you take it, but if you were to describe it in like a sentence or two, what's the main trick that Model to Vec brings to the table, such that you can still use word embeddings in a way that's reliable and better than what word embeddings did before?
Yeah, I think the real big thing is the fact that we use sentence transformers as static embedders. We distill them into static embedding models. That's the backbone of Model to Vec, is just that simple trick of not seeing a pre-trained transformer model as something that encodes a sentence, but as something that can also encode a single token, and that token can become a static embedding. That's what it started with.
Would it be fair to say that's kind of like a distillation technique? Like we've got this sentence transformer thing that's a little bit heavy, and from that we're going to distill the word embeddings. That's the main gist of it. It's just that how you distill them, there's some clever tricks there.
Yeah, exactly. I think it is. I would consider it a distillation technique. I think Tom Aarsen from Hugging Face called it aggressive distillation, which I thought was a really nice term.
Yeah, that sounds appropriate. but like the reason why I think it sounds appropriate is also, I think, like if we were to talk about the order of magnitude in terms of size difference, an average sentence transformer model is like a couple hundred megabytes, I think, right? Ish.
Yes.
And then I'm talking about the lightweight ones. There's heavier ones. Mm-hmm. And if you distill word embeddings from it, you end up with like 20-ish megabytes. Ish.
Yeah, 20 to 30. That's what our models are. Our biggest models are 20 to 30.
Exactly. So that fits on the Raspberry Pi quite easily, and not a lot of memory requirements on that one. But then how does it work? Because I think transformers, they have this attention mechanism, right? So a bunch of tokens, they all get turned into some sort of a word representation. Then there's a attention layer on top. Then word representations get mixed. There's a gradient descent at the end, but there's lots of these attention mechanisms. But the way that you go about it, I think, is you just loop over the vocabulary of a transformer model, right?
Yes, which is counterintuitive if you think about it, because attention is not designed for this. It's designed to have this representation based on attention between tokens, and we explicitly choose to throw away that whole idea and just have
idea of context thrown out the window. Like it was my first response as well. But that is accurate, right? Like you're really just doing one word at a time from the vocab, that embedding, and then next one.
Yes, that's true. Yeah, we throw away the whole idea of attention and context essentially. And
I can imagine, like, you're coming up with this idea, and what gave you the confidence to actually try this crazy thing is then the thing that I wonder. Because I'm sure, it feels kind of like an out there idea. The whole reason why we like transformer models is because they provide the context. And then you're going, well, what if we don't? Basically.
Yeah. Right? Yeah, I'm not sure. I think it was Stefan who tried it for the first time, who came up with the first numbers that were a little bit promising. But I think it was such an out there crazy idea that we figured, well, maybe nobody has done this. It is so simple, but also so counterintuitive that it felt like something that nobody had tried at that point. And that's why we decided, well, it's not a lot of work, obviously. Like the base idea is it's quite easy to set up.
And like, I remember back in the day, I used to write a lot of these blog posts where basically I had the same attitude. Like, this feels like crazy. It shouldn't work. But if it doesn't, I can at least write a cool blog post about it. Like, was that kind of the attitude as well?
Yeah, exactly. I think we could always write a blog post about it if it worked to some extent. I don't think both of us expected that it would work this well in the end. But what we did, that was for us, obviously really cool that we found something that actually works. But I don't think neither of us expected that this would work as well as it does.
Yeah, I can imagine. I mean, I do want to maybe take a moment and just appreciate the fact that probably more people should just do this. Because it kind of feels like a lot of these discoveries kind of happen by accident just because people are fooling around. but doing that consciously is maybe something more people should just go ahead and do, because before you know it, you've got like a great model on MTab, which is also kind of like a cool lesson here. But it's not just this, like, it's not just taking every vocabulary item and then grabbing the vector from the model that you folks do. I think there's like a couple of post-processing steps that you do as well, right?
Yes, that's true. So I will place it into two buckets. We have model to vec, the original idea, and then we also have Tokenlearn, which is a method that we developed afterwards. But the original model to vec is essentially what we just described. We forward pass the entire vocabulary of a sentence transformer through the sentence transformer and just take the individual token output embeddings. And those are then embeddings for all of the tokens. Then we do something which we call zip weighting, which I think is a pretty cool approach, because our tokens are essentially unweighted at that point, right? In a normal sentence transformer, you have the attention layer to sort of help you weight tokens appropriately, but we don't have that luxury. So we figured, can we do something with the fact that language follows a Zipfian distribution? So essentially the first word in a language occurs twice as often as the second most frequent word, and that one occurs twice as often as the word most frequently used after that.
Zipf's law, and correct me if I'm wrong, but I believe it doesn't go into too many specifics, but there's an empirical exponential relationship in the frequency of words. So the most frequent word is used almost one factor as much as the second most, but it's a frequency thing. That's what Zipf's law says. It's just a frequency thing.
Yes, exactly. It says that language follows a parallel distribution. That's the most basic way of putting it, I think. And what we also knew was that the vocabularies of all of these sentence transformers are sorted by frequency, which is really useful.
Yeah, that's an interesting side effect of the way that they do the byte pair compression trick. To actually, the way you find those tokens actually requires you to have that thing be sorted. It's kind of an interesting byproduct. But how do you combine those two things? Do you then say, okay, the stuff that's first, like that occurs super often, we're going to weigh that less because it's more likely a stop word? Is that sort of the trick that you do?
Yeah, that's the idea. So we literally put a Zipfian distribution over our output tokens. We make the big assumption that it sort of follows Zipfian distribution, our tokens, and then we apply that as a weight. And what that indeed does is automatically ignore stop words, because the first things in your vocabulary are going to be, well, the alphabet and very short tokens and words like the, and stop words that you normally would have to process out yourselves. But in this case, they get sort of ignored automatically because of this Zipfian weighting trick.
Gotcha. But it's okay. But that's just really a reweighing trick to make sure, because the thing with all these word embeddings, you still want to turn all these separate word embeddings into like a sentence or document embedding. So you do some sort of a pooling thing, like you add them together, I think, or you take the mean or something.
Take the mean, yes.
Exactly. But then before you do that, you make sure that, okay, the things that are likely stop words, according to Zipf's law, let's smudge those down a bit. And that has proven to giving you like higher numbers on the MTab benchmark, I think. That's the conclusion.
Yes, exactly.
Do you remember how significant it was, just out of curiosity?
I think it was like we have ablations on this, but it was like 3 to 4%, which is a big boost on the average performance.
That's definitely like substantial. Like if it's just 0.5%, you might go, it's different, but this is like 3% is a solid difference.
Yeah.
Okay, interesting. And then you do one extra step, I think, right? So after Zipf's law, you do like reduction, if I'm not mistaken.
Yeah, we do PCA, which is this one is a bit interesting, I think, or unexpected at least, because we wanted to apply PCA for dimensionality reduction. We thought, usually you can reduce dimensionality quite a bit without losing any performance. The sentence transformer that we used had 768 dimensions, which would lead to a larger model. We wanted to reduce it a little bit, and then it turned out that it actually boosted the performance by quite a bit. Yeah, so we got around a 2 to 3% performance boost by applying PCA, just because it recenters the output space essentially. Because if we were to do PCA without removing any of the principal components, we also saw this boost, which is very unexpected for us. But
I mean, the centering right, but it's probably due to the centering more so than removing information.
Exactly, it's definitely the centering, and then we could remove some information for free. That's how we ended up with these small models.
Right. But okay, but it's still kind of interesting. If you're really going to do aggressive distillation, throwing away some dimensionality there could make a bit of sense. But I can also totally see how, centering can definitely, especially with these retrieval tasks. Did you notice a difference between classification and retrieval in that one?
Yes. It made a very big difference in clustering and retrieval. It's really frustrating.
Yeah, because all those things use cosine distance, and for that, this can make a huge difference. So that makes sense. Okay, cool. The one thing I kind of wonder, is there also like a task you had in mind for this when you were trying it out, or you just thought just having something general for these word embeddings would be cool?
So the tasks I do normally involve classification and retrieval mostly. So those were the tasks we were really focused on. But I think when we started developing, we didn't have a specific task that we were trying to optimize. We just tried to optimize the average score of on MTAP essentially, without looking at the individual tasks so much.
Okay, now I didn't know about the centering, but all of this sounds super sensible. And of course, the end result is you've got static stuff on disk. It's pretty lightweight to move around. You can load it. You can even do like float 16 instead of float 32 stuff if you wanted to. So like the final artifact makes a lot of sense. But there was also this other technique that you're currently investigating as well, right? Because this is model to vec, I think, and there was also another one.
Yes, Tokenlearn. So Tokenlearn is essentially a technique we developed after model to vec to make the models even better. But all the models are still loadable in model to vec. Model to vec is essentially just our package for inference now. And then we have Tokenlearn as we call it a pre-training method for static word embeddings. And it's essentially a direct extension of the model to vec idea. So with model to vec, you had this nice light way of distilling your own sentence transformer model into static embeddings. And we figured, what if we can train these embeddings and make them a little bit better? And that's exactly what Tokenlearn does. So in Tokenlearn, we take a large data set. It doesn't matter what, it just has to be a general data set. We use C4, you can use FineWeb, anything you have at hand, basically. If you have domain-specific data, even better. And then we're going to use the sentence transformer that we have already distilled to generate embeddings for all the samples in that data set. Because those are essentially the gold standard sentence embeddings, right? For that data set. And that's what we hope our model can mimic. And then we take our model to vec model, which we've already distilled, and we put a simple linear layer after it so that we can train it. And we just have it produce embeddings of the same dimensionality and try to minimize the distance between those two embeddings. So
but in doing so, you don't add a layer on top. You really just change the original embeddings, basically.
Yes, only during training we have this layer because we need to have it be trainable, essentially. Have it.
Yeah, otherwise you don't get the backprop. But the goal is you still have that one little artifact, and then we're just going to do like a fine-tuning thingy, basically.
It's fine-tuning, and then we just throw away this additional layer that we used during training because the embeddings were unfrozen during training, and they get optimized to be better at becoming sentence embeddings.
One thing I wonder, you still need a data set in order to do this, right? Like you still have some text that needs to go in. Any thoughts on how to do that? Like, did you just take a random data set, or you take like something that Hugging Face offered, basically, or any reasoning there?
Yeah, we used C4. We also tried FineWeb, which are two very popular datasets for pre-training LLMs. I think anything that's sort of a clean representation of data you can expect in your task is going to work. For my day-to-day job, I use a scientific data set, scientific articles to make it a little bit better for our specific tasks. But really, I think anything works as long as the data is sort of resemblant of what you are going to see for your model.
Makes sense. Was it hard to, because I can imagine you need a bit of compute resources for something. I would imagine. I mean, your model's still kind of lightweight, but the data sets you're talking about, C4, sounds kind of big and heavy. Like how many gigabytes is it?
It's too large, but we only used the first million samples of it.
Right. Like you didn't go for the whole thing.
We didn't go for the whole thing. That would have been too much. And I also don't think we needed the whole thing. I think even a million was already, so we tried 300,000, 500, up to a million, and then we didn't really see any performance gain anymore during training. So we decided to just stop there at a nice little round million.
How much of a boost did this give? Do you remember?
Around 5%.
Oh, okay. So interesting. I mean, it makes sense. Like you spend more compute and effort in order to undo a little bit of the distillation damage, I guess.
Yeah.
But then if we were like to sort of make a comparison complete now, like if I were to say, I've got this base model from the sentence transformer library, like how close can I get with embeddings now? Like impossible to give a like really good number here. I get it. But like if you were to try to ballpark it, where would you get?
So we've compared directly to one transform, which is Minishlab, which I think is the most fair comparison. It's one of the most popular transformer models in the world. And I think a lot of people use it in production because it's actually productionizable. And Minishlab scores 56% on MTAP. We score a little over 50% on average. But then on classification, we actually outperform Minishlab by 2%. So I think depending on the task, you can actually get close or even better than transformer models.
So you could make the claim that, okay, if you want the most state-of-the-art, most accurate thing, don't go for this. But if your main requirement is lightweight, then this is definitely like a technique to give a look at. Because also I think you don't need a GPU for this. Like even the fine-tuning probably you can maybe do without it.
Yeah, we did it on a CPU. It works pretty well on an MPS, but yeah, you can do it on a CPU. It's fine. And the magnitude of speedup is really, really big. Obviously, it's in the hundreds times faster.
I'm kind of wondering if you ever thought about this, but I recently had a use case for this. I think there's also another bonus. Have you ever tried using these embeddings in the front end, like using Pyodide or something? Because Pyodide is an interesting one where I think we've got scikit-learn working in that space now as well as NumPy. It's just PyTorch. We're never going to, like, that'll be a painful thing to get working in your front end just because it's gigabytes and all that. But hang on, we now have an embedding model that's, you know, you can put it in the front end. So that can do a bunch of demo things. And sure, it's like a 20 megabyte thing that it's, you know, not great, but doable. Have you ever tried that out at this point?
Other people have actually. Yeah, I'm not a front end guy, it was also not a use case that was really on my radar. But one of the first questions we got right when we open sourced this was from multiple people. Can I use this with Transformers.js, which is this front end, which is a web framework for transformers? Yeah, web thing, which is not my thing, but apparently it's a really good use case, like having this run in a browser and do things for you, because it is so small and lightweight, and you can essentially run it in your browser, or as you said, in the front end application. So yeah, it's not an application I've tried myself, but it's something other people have tried.
Yeah, I'm gonna have to try. Like, when you've got this Pyodide Jupyter project, like JupyLite, Lite, and you've got NumPy working in that and a whole bunch of things, and all of that is just running in the cloud. But one downside is that getting PyTorch to work is just, in my mind, never going to happen on the short term. But this actually could work in that thing very well. So even if you want to do lightweight embedding stuff, all client side, not having run that on your server, I think this is also kind of like a really nice use case. Yeah. So a final thing I'm kind of curious about, whenever I talk about embeddings, I always kind of feel like it's fair to mention that most data sets are English, but most languages aren't. Like, something to be said about that. Have you heard anyone sort of try this out for different languages that got different results as well? Like, I can imagine Dutch is very similar to English, so Dutch is probably also just kind of fine in that sense. But I can also imagine this trick doesn't work well for every language out there.
Yeah, I think so. We've distilled a multilingual model as well that we released, and we do plan on actually pre-training one of those as well using the Tokenlearn method. But obviously for that we need a multilingual data set, a bit more work. One really difficult part about this multilingual aspect is evaluating it, because MTAP, it has a few languages like English, Chinese, Russian, some of the big languages, but it doesn't cover hundreds of languages.
I was about to say, and even then, I think it's mainly English, right?
It is mainly English. Yeah, exactly. So it is very hard to evaluate this. What we did for one of the models we distilled ourselves and released as our multilingual model was just trying it out on some very basic tasks, like seeing if the embeddings for the word dog in different languages if they end up projecting to each other, things like that. But apart from that, we haven't tested it for any real multilingual task yet. It is big item on the roadmap though.
Yeah, and I can also imagine, I did some of this embedding stuff back when I was at Rasa, and at Rasa I very quickly came to the conclusion that, I don't know, like if I have embeddings that work for Arabic, then I need someone with an Arabic use case to tell me if it's a good embedding. Like, I'm not necessarily in a very good position to judge that. And I think that's probably also going to be the thing here. Like, you're going to need the community feedback in order to really nail this one on the head. Cool. So one thing to slightly pivot, because I think this technique is nice. Like, it's cool to see stuff like this happen. But not only did you explore an open source package, I think you've also started a lab around this, if I'm not mistaken. And yes. I thought that was just kind of curious, because I don't know of a lot of people that start a lab in their spare time. Like, something about that. Also kind of felt like, hang on, there's probably a little bit of a story there. There's probably to discuss it. So what's this? Okay, you started a lab around this kind of. Like, what's the story there?
I think it was sort of, I wouldn't say it was a joke at first, but Stefan and I were working on this. We were both putting all of our free time into this.
I'm not saying it's a joke, but I am saying this while smiling big.
Yeah. No, the way it started was really, whose GitHub account is this going to end up on? Is this going to be Stefan's account? It's going to be my account. So we need an organization on GitHub. We thought about the name, when we came with the Minish Lab for both big Zelda fans. You have the Minish Cap, which is an old Zelda game. That's what the name is based on. And Minish is old, yeah.
I only started playing Zelda like 5 years ago, so like that's completely. And that does paints a picture. Got it. But interesting starting story as well. Like, okay, we need a place to put it, so let's come up with a name, and then ball starts rolling. All right.
Yeah. And then obviously we got into the whole marketing thing. We were thinking, like, how do we market this? Well, let's make a LinkedIn organization for this. So we also made it a LinkedIn organization, the Minish Lab. And then after that, I think when we open sourced it, we got a lot of really good feedback on the first day, a lot more than we expected. And after that, we decided we love doing this. We're just gonna turn this into a lab and actually spend most of our free time on.
And actually go to LinkedIn and say that you work at a place, but also that you run a lab. Like, that's also the step that can do that.
Exactly. And really trying to professionalize it, not just putting out this single package, but trying to build multiple, being active in the community, writing blog posts around the work we do, things like that. And that's kind of how it started.
So it's maybe not so much a lab at this point, but it's more like a hobby that you would like to attach a brand onto, kind of, as well. Like,
yes,
it's also kind of, it's not like you're going out there to get research grants or anything like that, but you do want to have like a banner of sorts where some of the stuff can live under, and then it's also a little bit more official that way.
Yeah, exactly. Yeah, that's kind of what it is at the moment.
So one thing that's also interesting, I've met so many people that start an open source package, and the main advice I find myself giving them is that when you start an open source package, think of the marketing. Like, that's a step that people tend to forget. It's, if you want to write a thing for your own, it's also just completely fine, of course. But in the end, if you want to have a community around it, you got to invest a little bit in the marketing thing of it. So it's good to hear that you've done some of that. But any lessons on that front from you? Like, if you were to think like, hey, what were some good decisions and like things that helped early on with the marketing of this thing? Like, one, have a good thing. That helps. But any other comments?
Yeah, I have a couple. So the first thing is really don't underestimate marketing. It is going to be, if you want something to be popular and this is your first thing, like was in our case, you really have to put effort into this. This is going to take some of your free time that you'd rather spend coding. That's just
playing Zelda.
Yeah, or playing Zelda games. Yeah, exactly. But also something we did, like where we asked friends and family, colleagues to give us a star. And the first day that we released it, like reaching out to people. And asking them to actually try it out for themselves and help us find bugs and things like that. Because at that point, we'd been working on this together with just the two of us for months without having external feedback yet. And so those two things really helped. But then obviously we also had to get a bit lucky, which we got. We got some, Tom Myerson from Hugging Face picked it up when we released it, posted about it himself, and that gave us this really
the maintainer of sentence transformers as well.
Exactly.
Like highly relevant
highly relevant person. Yeah, exactly. Yeah, so that was obviously a really big boost. I'm not sure if we would have gotten it this big if it weren't for him and him helping out. He also integrated into sentence transformers as technique, so that obviously helped a lot. And also, don't get discouraged when marketing, because the first few times we posted something, nobody reacted to it. I remember spending a bunch of time on writing a Hacker News post, like a show Hacker News, which we're absolutely above on, and we got like two likes or something. Yeah, exactly. And we felt pretty bad about that. In hindsight, it wasn't the best post. It wasn't very marketable. We were way too scientific about it and not actually marketing.
Well, but those it's funny. It's interesting you mentioned it, because I do think there's an interesting rookie mistake there as well. Like, not necessarily if you're just an academic. Like, if you're an academic, this advice would apply. But even if you're just a student, like even if you've just been exposed to the academic writing, which if you've ever written a thesis, you are, a good blog post is very unlike a thesis. Very unlike a thesis. Yes. And there's a place for a thesis, and there's a place for academic writing. And you should definitely feel free to be rigorous in your benchmarks. Like, that's the thing to appreciate there. But a blog post needs to be readable, skimmable, have a good chart. Like, it's a different medium in a way.
Yeah, exactly. Yeah, I completely agree. I think Stefan had already been blogging a while, like doing these nice little blog posts himself personally. So he had some experience there, luckily, on how to actually write something in a grounded way, but not very academic, like not dry, something that really is captivating for your audience. So I think our blog posts turned out quite nice because of that. But that is definitely something to take into account. You don't want to write academic articles, when you open source a package.
Yeah, so part of me does. It's an internal thing I've always wondered about. Like, would the academic world maybe be better if it was more like blog posts? I don't know, because I do think, even though the review process of these articles, everyone loves to complain about them, but they probably also have a reason that reviews are sort of also a good thing sometimes. And I don't know, but part of me is very happy with the fact that a lot of us don't need an academic background in order to push something onto a GitHub or a Hugging Face thing, for that matter, in order to sort of, I guess, like, another thing that people always forget is, like, if you want me to try out a thing, there should be one line that says how to install it and the thing I can copy in a notebook to run it. Like, that should be the only two. Yeah, that's also a step that some of these more academic projects sometimes also miss.
Yeah, exactly.
I guess, like, a small pivot then, because, I guess this is like the main success story, I think, of the lab at this point. But it's not the only thing that you're doing. Like, you're doing something with embeddings, but it's if I've had a look at your repo, there's also some other stuff that you're working on. One thing I noticed that you're doing something with retrieval. That's like a thing that's in there. So, like, just real quick, like, what does that do?
We're doing a couple of things at the moment. So I think you're referring to Korok. It's another Zelda reference.
It makes sense now. It all makes sense now.
So we're doing something called Korok, which is a retrieval pack. That one is really unfinished, though. I think that's the most experimental thing we have at the moment. And the only reason it's open source even is because we had an outside contributor who had an idea for a vicinity, which is one of which one of the packages we actually released, which didn't really fit into that package, but it was something that would fit nicely into the idea behind Korok.
So I was actually referring to the vicinity one originally, but let's first talk about Korok and then we can talk about vicinity.
Right. Yeah. No, Korok is really still something we're thinking about. We want it to be something like a very, very lightweight way of working with vectors. Like, I don't want to say vector database because that's already too heavy, but something just with very minimal dependencies, very fast and very easy to use for people. And then offer a bunch of things like re-ranking, hybrid retrieval out of the box, and also have inference just in there. A lot of vector databases as the starting point have embeddings. I just want it to be text because model-to-vec is that fast. You can just instantly inference embeddings and then query them. That's kind of the idea.
Yeah, and this is like just all in memory using NumPy, basically trying out the lightweight stack. And I forget which one, but I also recall a couple of tweets and blog posts from Andrej Karpathy where he, like, some of his earlier work was also just do everything in memory with not even an index, just do brute force. And lo and behold, if you only have 10,000 documents, that's faster than building an index. Some of that stuff is actually interestingly true in that sense. But one thing I'm observing then mainly is, because Vicinity, if I recall correctly, that is kind of like an umbrella for different backends to do vector index lookup stuff. But you are building a stack then at this point. Would that be fair to observe?
I think we're building a stack, yeah.
And then the main audience initially is you, and you're kind of just, you're going to write blog posts about it now and again. You're trying to make it clean such that the larger community can go ahead and use it. But that's kind of like you're trying to build a brand of and a stack of tools, I guess. That's kind of where
Yeah, I think that's true. And I think we're still pivoting a lot. Obviously, it's early days. When we started, we had three things that were important whenever we would build something new. The first one was obviously we need to have fun and learn while doing it. The second one was we need to be able to use it at our day-to-day jobs. And the third one was it needs to be something that can become popular. And we sort of ranked those and then came up with the way we want to work together based on that. Because obviously you're going to work in a very different mindset if you're working to build popular packages. Like we're explicitly not in the LLM space, the generative AI space at the moment, because it's not something we enjoy so much. But obviously it's a very good space to be in at the moment if you want to have popular packages.
Yeah. Or you just say you wrote it in Rust and then 16 VCs will pop out of nowhere.
Exactly. That's also a good trick.
Well, but it also makes sense. Like I remember back when I made this package called Embedder, which is a thin wrapper around some stuff that you can go ahead and use it in scikit-learn. And I do remember like this talk I have with myself, like how general do I want this to be? And I noticed that, okay, I can do text and I can do images and all that stuff fits the scikit-learn API. Oh, and I could do nested stuff. Oh, actually, that doesn't fit the scikit-learn API. Oh, great. So I don't have to consider that. Like giving yourself permission not to evolve beyond the sort of stick in the ground is also kind of like a nice permission that you can give yourself in that sense.
Yeah, exactly.
So in that sense, kind of going towards wrapping up this bit, but one thing I wonder, like we've been talking about the tools that you're working on. I think it's mainly going to be text going forward and mainly the theme of lightweight and seeing if you can sort of build a little garden around that idea. But I can also imagine that as, you're becoming more professional, the world around you is changing, there's new packages and stuff and new techniques. Are there things that you aren't going to be working on yourself or that do kind of excite you? Stuff that you're seeing around you? Because one thing I wonder, like, there's not a lightweight computer vision thing, now that I think of it. Like, I could be wrong on that one, but I think there's like some lightweight computer vision stuff for these embedded devices, but I'm not aware of like a lightweight embedding model for like a NumPy, like what you folks are doing. I know, like, are there things that you're sort of looking at that might inspire you?
Maybe. I mean, we're both not really into computer vision, as in we don't do it in our jobs. It's not something, I did it in college, but that's a long time ago already. We did get a question immediately about that. Can we also use this for images? The idea behind model-to-vec, and the short answer is no, you cannot. There's no vocabulary. You need to come up with some way of turning patches of images into a vocabulary or something to actually do this. But I think I just don't have enough theoretical background at this point to come up with a really good idea in that space compared to NLP, and that's why I don't feel like it's worth the time for us to
it makes complete sense. But I can imagine, at least personally, in this age of like LLM stuff, I do think it's just kind of badass to say, I'm not going to do that. I'm just going to do lightweight stuff. But if you have that attitude, then also you kind of look at the landscape a bit differently. So I'm kind of wondering, like in general, tools that you're paying attention to or techniques that you think might deserve some more attention from the crowd in general.
Yeah, I think there's like interactions between, obviously people are moving towards generative AI. Like people are going to use it in production, are already using it in production. There's no way to stop that. And I think there are really good use cases for it. But I think interactions between that and the lightweight stuff are really cool. There's this library called Chunky, which is a chunking library, which uses...
I think I saw that. Is that a Hugging Face thing?
It's not a Hugging Face thing, no, but there's probably some attention from Hugging Face. It's gotten quite popular already. But we were a bit of contact with the maintainer of that package, and they added Model to Vec as one of the default backends for semantic chunking there. But
I think I saw. Yeah, this totally rings a bell. It's the hippopotamus logo.
Yeah. Exactly. Yes. Yeah. That's I think a very cool lightweight package, which really fits into this design philosophy that we also have. But I think there's a bigger space for like truly lightweight stuff than I thought there would be. Like also keeping your dependencies really low. But one big mistake we made with the first release of our package was having Torch as a base dependency. Yep. It was actually a suggestion by you to turn that into NumPy. That was our biggest thing in the 0.3 release, was removing Torch as a base dependency. And that opened up so many new use cases.
We should maybe explain that one a little bit.
Yeah, we should probably.
I like doing these live streams, and when I do, I think it's always fair to sort of reach out to the maintainers. And I tried under Stack. I thought there was stuff to like. It's just there was this one thing that always surprised me. Like if you're really going for lightweight, it feels like you're distilling, and then at the end you end up with these NumPy arrays basically. And from that point on, you can kind of move on without having any PyTorch around, and that's totally going to make your Docker container a whole bunch smaller. So that was just a very normal, mature conversation we had quite briefly, and like within a week, I think you posted a version of PyTorch. It was super nice to see. I'm reminded of one extra question I had though, because we discussed a couple of things. One thing that we also discussed was, because right now you take the mean, I think, of all the vectors in a sentence, right? And I remember back at Explosion when talking to some of the Spacey maintainers, they do some similar tricks with pooling, but they don't just take the mean, they also take the max. That was a thing that they tried, and they would concatenate both pooling methods next to each other. Did you try any of? We talked about it briefly. I don't know if you've tried it.
So we tried only for Model to Vec, actually. We didn't try it with Tokenlearn, so that's actually an interesting experiment we could still run. With Model to Vec, we tried just that idea of concatenating the max vector after the mean vector, and that didn't give us a performance boost. But maybe with the Tokenlearn methods, you get to get to distill, so the gradient they can actually maybe learn to optimize those vectors. So that's a pretty interesting idea.
I can imagine there's a degree of freedom there that you gain, right? Like that could be beneficial, maybe. Kind of hard to say, but actually, now we're getting full circle. I guess the only way to figure this out is to actually allow yourself the creative freedom to run this brain fart.
Yeah, exactly.
It's part of lab, basically.
Exactly. Yeah.
So I think that's a lesson that people should take home, though. Like sometimes the thing that I really enjoy just from looking at this, I think more people should allow themselves the creative freedom to, just try out a whole bunch of stuff, because there is an odd chance that it's actually turning out to be a good idea, and then people should maybe make a small little lab around it. There's too many of these ideas that get forgotten or that people don't necessarily go for. And I definitely think like the world would be, like the AI space would be much better if we had lightweight alternatives like this. Like the world needs more of this. I think I can deploy more stuff on my Raspberry with stuff like this. Like that idea I think is very, very powerful. So thanks for being on the show. Thanks for the good work. If people want to learn more about this and maybe find you, like how can they do it?
So we're on LinkedIn and under the Minish Lab. We're also on Github under Minish Lab as an organization. We're on Hugging Face, again, Minish Lab as an organization. And then obviously you can find our personal accounts on LinkedIn if you want to reach out, which is Stefan Tulkens and Thomas van Dongen.
Very good. Yeah, no, this is a great conversation. Thanks for being on. See you around the internet. And let's keep things lightweight.
Super. Thanks, Vincent.
Thanks for listening to this episode of Sample Space, and thanks in particular for making it all the way till the end. I really hope you're enjoying these podcasts that we're making here over at Probabl. If you're interested to see more, you can find the podcasts on your favorite podcast player, but you can also go to our YouTube channel. And if you're interested, you can also reach out to us on socials. You can find us on LinkedIn, but we also are getting more active on Blue Sky these days. And in particular, if you want to speak to me personally about maybe some guests I got to interview, you can also find me as well as many of my colleagues on our Discord. Go to discord.probabl.ai, you'll find us there, and feel free to give us any feedback you might have. I hope you enjoyed this episode, and see you again next time.